Okay, so let's talk about the sine rule, cosine rule, and the area of a triangle. So first we need some notation. So let's say we have a triangle, right? Let's say our triangle looks something like this. And this is not a right angle triangle. So the whole point is, what if the triangle is not right angled? Then how do we find lengths, angles, and the areas of those triangles? So we call the sides by lowercase letters. So let's call this side A. Let's call this side B. Let's call this side C. And then the angles opposite to the side. So for example, for this side right here, the angle opposite to it is this right here, right? We call this angle capital C. This angle would be capital A then, because it's opposite to lowercase a. And then this angle right here would be capital B. That's just some notation. So now, how is it useful? So we have three things. So we have A divided by the sine of A is equal to B divided by the sine of B, which is also equal to C divided by the sine of C. So this is the sine rule. And you can switch those around. So you can be like sine A divided by A is equal to sine B divided by B is equal to sine C divided by C. That's the sine rule. Now what's the cosine rule? I would say the cosine rule is more important. So the cosine rule says that A squared, so this is the side, remember, the side A squared is equal to B squared, this is also a side, plus C squared, this looks like the Pythagoras theorem, and then minus 2BC, and then this here is the cosine of the angle A right next to it. So for example, if I want to find this side right here, I would take the square root of this squared plus this squared minus 2 times BC times the cosine of this angle right here, which is opposite the side A. We'll do some examples and it will make more sense. And then the area of a triangle. So the area of a triangle, because once we had right angle triangles, we knew what to do. It would be a half base times height. And this one is similar, but this is now a half times AB sine of C. So let's say I want to find the area of this triangle. I would do a half A, B, and then C would always be the angle in between A and B. So I would do the sine of C. But this is also equal to a half, let's say I multiplied A and C, then I would have the sine of B, because that's the angle in between A and C. And then of course, if I want to do the other one, I would do a half B times C times the sine of the angle between B and C, which is of course A. So that is the area of a triangle. Now, this is all a lot of things to memorize. It's probably a good idea to memorize them, but once we do some examples, it will make more sense on how to use them. So let's do this question right here. So the diagram shows triangle ABC on a horizontal ground. So that's the triangle. AC is 15, that's given. BC is 8, and AB is 20 meters. Okay. BP and CQ are vertical poles of different heights. So this is BP and that's CQ. BP is 3 meters, CQ is 4 meters. AQ and PQ are straight wires. Okay, so just a diagram. Show that angle ACB, so that's that angle right there. Show that that is equal to 117.5 degrees, correct to one decimal place. Okay, so the perfect place to use the cosine rule is this right here. So the cosine rule says A squared is equal to B squared plus C squared minus 2BC cosine of A. Okay, so now we need the angle. So we need cosine of A on its own. So if we rearrange the equation, we would have, let's bring this minus 2BC cos A to the other side. So we would have 2BC times the cosine of A is equal to B squared plus C squared. And then bring the A squared to the other side. So we would have minus A squared. Then if you want cos A on its own, you would have cosine of A is equal to B squared plus C squared minus A squared divided by 2BC. So what's A, what's B, what's C? So since we're finding this angle right here, this would be our capital A, which means that this right here would have to be lowercase a, because that's what we saw right here, right? The angle is always opposite to the side. So we have that established. And now B and C don't really matter. We can call this B and we can call this C, because those don't really play a part in this. So now what do? We have cos A is equal to that. So that is equal to B squared, so that's 15 squared, plus c squared, so that's 8 squared minus a squared, and now that is 400 because that's 20 squared. I'll write it as 20 squared, so we just keep it consistent. Minus 20 squared, write that better, minus 20 squared divided by 2 times b is 15 and c is 8, so divided by 2 times 15 times 8. So that is equal to, I did it somewhere here, so you would have 225 plus 64 minus 400 divided by 2 times 15 is 30 times 8 is 240. So you would have that right there. And then to find the angle, you would just do the cosine inverse. You would do shift cos of that number right there. So let's put that into my calculator. You have 225 plus 64 minus 400 divided by 240. So cos inverse of negative 0.4625. And then for sure that would end up being 117.548 degrees, which is 117.5 degrees correct to 1 decimal place. So we're correct. That's fine. Let's go to the next part. Calculate the area of the triangle ABC. So ABC, so that's our triangle right there. Well, remember the formula says the area is a half AB sine C, or a half AC sine B, or a half BC sine A. Now, if you wanted to multiply A and C, we would need this angle right here, but we don't have that. That would be angle B. If you multiplied A and B, we would need this angle right here, which would be angle C, but we don't have that. If you want to multiply B and C, we would need the angle A, but we do have that because we just calculated, right? We just calculated that that angle is 117.5 degrees. So now our formula would be a half BC times the sine of A. And that is just a half times 15 times 8 times the sine of 117.5. It's 117.5 because it's at 1 decimal place. And that is equal to, I did it somewhere, that is equal to 53.22. 53.22 meters squared. So that is the answer for the area of the triangle ABC. 53.22 square meters. Okay, next part. Calculate the length of AQ. So what's AQ? AQ is just that. And this is already a right angle, so this has nothing to do with trig, this is just Pythagoras. So we know a squared is equal to b squared plus c squared, that's just Pythagoras. Pythagoras' theorem. A squared is equal to b squared plus c squared. That means a is equal to the square root of b squared plus c squared. In our case, a is the hypotenuse right here. So this is the length we're trying to get, x. Well, that's just 15 squared plus 4 squared and then the square root of all of that. So that is equal to the square root of 15 squared plus 4 squared, which is equal to the square root of 241, which is equal to 15.52. So that's the length we need. So that's our answer for that. That was pretty simple. Calculate the angle of elevation of Q from P. So what does that mean? The angle of elevation of Q from P. That means let's draw a line. So let's say we draw that line right there. Let's say we have that line right there. What it's asking for is the angle of elevation of Q from P. That means if you're standing at P and you want to look at Q, what angle would you be looking at? And that would be that angle right there. That's the angle of elevation. So how do we get that? Well, we know this whole thing is 4, but we know that this right here is 3. That means this length right here would be 4 minus 3, which is just 1, because this is 3. And then that would just be 1, because 3 plus 1 would make 4. So you have 1 right there. And then this length right here is the same as this length right here, which would be 8, because they're parallel. So you have 1 and 8. And then remember SOHCAHTOA, right? So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and then tangent is opposite over adjacent, SOHCAHTOA. So here we need the angle x, or let's call it y. Well, we have the opposite and we have the adjacent, so we would use TOA, we would use tangent. So we would have the tangent of y is equal to the opposite divided by the adjacent. So the opposite is 1 and the adjacent is 8. So you would have 1 divided by 8. And that means that the angle y is equal to the tan inverse of 1 over 8. If you put in your calculator, you get 7.13 degrees. So that's our answer for that, 7.13 degrees. So we're good. Another straight wire connects A to the midpoint of PQ. Calculate the angle between this wire and the horizontal ground. Okay, so that's more difficult now. Connect A to the midpoint of PQ, angle between wire and horizontal ground. So A to the midpoint of PQ. So now, what do we need? Let's remove all these other things that we have. We don't need all these other things. Wait, I just removed what I didn't want to remove. Wait, this is 7.13. That's fine. Okay. We can't really remove those things, but I guess I could erase them. So I'll erase these right here. Erase that. We don't need this anymore. We already calculated this. We need to erase that. Erase that. We can keep that line over there. We can keep these labels. Yeah, we can remove this x right here. We don't need that. We know the value already. Do we need anything else? I think we're good. Okay. So, if you draw another line now, it says from A to the midpoint of PQ, so that's that right there. Okay, and we need this angle, so let me remove this first, because this will confuse us, because this is not C. But we need this angle right here, the angle of elevation. That means from the ground looking up, what is that angle equal to? Let's call it X, question mark. So, again, we have another triangle. So, we know what this is right here, right? This is just 3.5 because it says midpoint of PQ. That means this is 0.5. 0.5. And then this right here will also be 0.5. Because remember, this thing right here was 1 and this was 3. So that means this is 0.5 and then that would be 0.5. That would add up to 1. So we have 0.5 right there. That means this whole length right here. So let's draw this triangle again. We have a triangle that looks like this. It's not right angled, it's just the way I've drawn it. This length right here is 3.5. Now as soon as we find this length right here or this length right here, we're good. Then we just use tangent and we'll be fine. Actually, that is a right angle triangle. What am I saying? That would definitely be a right angle triangle because this is perpendicular to the thing. It goes straight down. Okay, so let's try and find this length right here. This is the easy length to find. We have that right there. Because we already have the angle given to us, we have that angle is 117.5 degrees. So what do we do now? Well, to find this whole length right here, we need to notice two things. We have that length right here, 15. We have that angle, 117.5. And we also have this length right here. That is 4 meters, right? Because this whole thing is 8 meters, so halfway through that would be 4 meters. Because this is halfway through, and then you draw a line downwards, and then you cut this halfway through as well. So that's 4 meters. So what we actually have is another triangle that looks like this. We have this, this, and then we have this right here. Right, and that's 15. That's the angle 117.5, and that is the length 4. So to calculate this length right here, let's call it y, for example, right? Well, we know how to do it. We use the cosine rule again. So y squared is equal to 15 squared plus 4 squared minus 2 times 15 times 4 times the cosine of that angle, which is 117.5. We know that already from the cosine rule, right? That's the angle 117.5. That's the length 15. That's the length 4. So what do we get? We get y squared is equal to, let's put it in the calculators. We get 15 squared plus 4 squared, so that's 241, minus 2 times 15 times 4 times cos 117.5. So we get minus 55.41. So then our y is equal to the square root of that, so that I put that in my calculator, and that's 17.217. So y is equal to 17.217, and that's what we need. So that's our length right here. So that's 17.217, and that length is this length right here that we needed, 17.217. And what are we finding? We're finding this angle right here, which we called x. So you can see we have a right angle, we have an opposite side and we have an adjacent side. So what do? We know the tan of x is equal to 3.5 divided by 17.217. That means x is equal to the tan inverse of that. So we do 3.5 divided by that, and then tan inverse will give us 11.5 degrees. And that would be our answer for this question right here, 11.5 degrees. I did all the working out right here instead of doing it in the place where I was allocated. I was meant to do it, but all we had to do was recognize that this length right here would be 0.5. That means this whole thing is 3.5. And the main thing that we needed was this length right here for this lower triangle. And that was only possible to find with the cosine rule. As soon as we found that, we realized we have a right angle triangle. And we just need to calculate the tangent for that angle right there. And we got what we needed. We got 11.5 degrees, and that is the correct answer for that question. So yeah, I hope that makes sense to you. Do some more practice with the sine rule and the cosine rule. We didn't really use the sine rule in this question right here, but that's because the cosine rule is just way more powerful. It has way more applications. Sine rule you would use, let's say you had something like this. Let's say you had a triangle that looks like this. Let's say that's a triangle. Let's say I gave you the length 6, and then I gave you the angle here is 55 degrees. And then this length right here is, let's say I gave you 7, and I told you to calculate this angle right here. Let's say x, right? Well, what do? Well, we know 7 divided by the sine of x is equal to 6 divided by the sine of 55. I'm only doing this question so that we have an example for the sine rule. I just made this up. So what do? Well, we can bring sine of x to the other side, so we have 7 is equal to 6 times the sine of x divided by the sine of 55. So that means the sine of x is equal to, well, if you multiply by sine 55 on both sides, you get 7 sine 55 and then divide by 6. So you would have 7 sine 55 divided by 6. And then you would find the sine inverse of that. So you would find the sine inverse of 7 sine 55 divided by 7 sine 55 divided by 6. So you find the sine inverse of 0.9557, and that is equal to 72 degrees, 72.9 degrees. So we have that right. So that means this is 72.9 degrees. And then from here you can fill out the whole triangle. That means, you know, this angle right here would be 180 minus 72.9 minus 55. So that's 52.1 degrees. And then you can use the sine rule again. So let's call this length right here y. So that means y divided by sine 52.1 is equal to, now we can choose whatever we want. We can do 7 over sine 72.9, or we can do 6 over sine 55. Let's do 6 over sine 55 because we already had that given. So we have that right there. Then we would do 6 times the sine of 52.1 divided by the sine of 55, and you would get that length y is equal to 5.78. So that is equal to 5.78. And yeah, that's the application of the sine rule. We were just given 2 sides and an angle, and we managed to get the other 2 angles and the other side as well. So yeah, that's the sine rule. We saw the cosine rule many times. We saw it 2 times in this question right here. That was a pretty serious question. And we saw how to calculate the area of a triangle as well. So hope you enjoyed the video. If you did, please like, share, subscribe, and comment, and let me know what else you want to see in future videos.